variance of a binomial random variable. Okay, so first recall that inside-outside formula that for any random variable at all in the world, expected value of x squared minus the expected value of x quantity squared is the variance. Okay, so I've already got the mean. I know it's NP for a binomial. I'm just going to get the expected value of x squared. By the way, that's called the second moment. We'll talk about that later. This is called the second moment. So for again, for x, for this, if x is distributed NP, then this means that the expected value of x squared, I should be able to write that as, remember we have this theorem that tells us how to write down expectations of functions of random variables, right? So I'm just going to take all the possible values that variable can take on and square them, because that's what the function tells me to do. And then take the weighted average against the probability mass function, okay? And choose k times p to the k times 1 minus p to the n minus k, okay? Okay. All right. So it looks a lot like the expected value of it from that last video, except we've got a 2 here, okay? So I'm going to start playing some more summation games here. Let's see. First thing, maybe I could factor a k, I could factor a k out of the bottom here and do some canceling, right? And also note that this first term is going to be 0, just like it was in that last thing that we did, whatever that was, right? This is a 0, okay? So I'll just start with 1 there. And let's see, I can write this as k times n factorial over k minus 1 factorial n minus k factorial p to the k times 1 minus p to the n minus k, right? See that? So I've done 2 things in this step. I've noted that the first term here is 0. If k is 0, all of this is 0, right? Also, I've factored out in the bottom, right, that there's a k factorial in the bottom here, but I've factored out a k, or I've canceled the k from the top and the bottom there to get this, okay? All right. Next thing, let's see, maybe I'll, gosh, we had so much success factoring out that n and p last time. Maybe I'll try doing that. I'll try pulling an n and a p out and see what we get. I'm just sort of fooling around here, okay? So if I do that, I'm going to have a k out to the side here and an n minus 1 factorial in the top, and right, because I pulled an n out, and I'll have n minus k in the bottom factorial times k minus 1 factorial in the bottom. I changed the order there for no particular reason. And now let's see, I'll take got a p to the k minus 1 and a 1 minus p to the n minus k, right? Because I pulled that p out. It's over here now. Alrighty. And so now at this point, maybe maybe we could try doing that change of index trick again. Remember last time, sometimes if you're really familiar with sums that start with 0, then why not just make it start with 0? Just change the index here, right? Look, see, if k equals 1, this stuff is 0 factorial anyway. So again, I'm going to set k prime equal to k minus 1, so that also this would imply then that k equals k prime plus 1 in case I need that. So the sum now is, I can write it as k prime goes from 0 up to n minus 1, okay? And then I have a k prime plus 1, that's what my k is. K becomes k prime plus 1. And then n minus 1 factorial over, k minus 1 is k prime factorial. Okay, and then I've got n minus k. N minus k is going to be n minus k prime minus 1. That's factorial. And then I've got a p to the k prime, and I've got a 1 minus p to the n minus k prime minus 1. Just barely got it right on the line right there. Okay. All right. Now look at this. I can split this. These terms in here, right? I can take k prime times all this stuff plus 1 times all this stuff. That's going to be real useful to me, I think, because if I didn't have the 1 there, this looks a lot like the mean of a binomial. And with just the 1 there, hey, that looks like something else. So yeah, let's rewrite that so that we can see that pretty clearly. In fact, I do it like this. K prime equals 0 to n minus 1 times k prime times n minus 1 factorial k prime factorial n minus k prime minus 1 factorial, here's a p to the k prime, times 1 minus p to the n minus k minus 1 prime. How many primes on my k's? Right. And then plus, I got that sum k prime goes from 0 to n minus 1. Just 1 times all that stuff, right? Hey, you know what though? All of this stuff right here, this is just n minus 1 choose k prime, isn't it? N minus 1 choose k prime is what that is. So I'm gonna note that. I'm just gonna write that here. N minus 1 choose k prime, and then I have a p to the k prime. There's 1 minus p to the n minus k prime minus 1. Close her up there. And now look at what you have here. All of this first summation here is just the expected value of a binomial random variable with parameters n minus 1 and p. Okay. And this stuff is just 1 by the binomial theorem. Okay. So all this stuff reduces to, got the n times p out there, and then what's the mean of a binomial n minus 1p? It's n minus 1 times p, okay, plus 1, okay. So all this is, I guess I could write it like, well, like that, I guess, n times p times np minus p plus 1, okay. So finally, remember, you have to take all this stuff and stick it back in to get the variance. Remember, all we did there was we just found the second moment, the expected value of x squared. Okay, so the variance of x then is it's the expected value of x squared minus the expected value of x quantity squared. So that's, now let's see, so I just found all this stuff. That's np times np minus p plus 1 minus the expected value of x is np. I'm going to square all that. Okay, so that's n squared p squared minus n p squared plus np minus n squared p squared. Right? And so I get some canceling there, and I just get np times 1 minus p, and there we go. Fantabulous.